Hello viewers, Ronald taking you through this tutorial for O-level mathematics. In this video, we're going to go through the solutions of a mock paper of mathematics paper 2. So this video is suitable for students of senior 4. Now these are the instructions which I believe you are very familiar with. So what I want to emphasize is that section A you have to answer all questions, but section B you answer only and only 5. Now for the sake of revision, in this video I'm going to answer all the 17 questions. So just start with section A questions. Question 1 says find the highest common factor or HCF of 420 and 780. So we have put this 420 and 720 here. So we have to look for common prime numbers which can divide both these values. So the product of those prime numbers will be the highest common factor. So if you look at 420 and 780, 2 can divide both of them, and when 2 divided by 420 you'll come up with 210, and when 2 divides by when 720 is divided by 2 you'll come up with 390. So still in this case 2 can divide both numbers. So 210 divided by 2 you'll come up with 105, and 390 divided by 2 you'll come up with 195. Then both these numbers are divisible by 3. So 105 divided by 3 you'll come up with 35, and 195 divided by 3 will come up with 65. So still they are divisible by 5. So 35 divided by 5 you'll come up with 7, and 65 divided by 5 you'll come up with 13. So these ones now have no common divisor, therefore we shall stop there and come and see that HCF will be equal to 2 times 2 times 3 times 5, which is this 2 times 2 times 3 times 5, and when I simplify I'll come up with 60 as my HCF. So that's what they wanted. Now let's see how much can be awarded. So M1 for the whole of this column of 420, another M1 for this column of 780, M1 for multiplying this, and A1 for the output. Now we shall go to question 2. Question 2 Roman 1 says that if logarithm of m is equal to a and logarithm of n is equal to b, express log in brackets m squared plus m squared multiplied by n in terms of a and b. Then Roman 2 says solve log of x base 3 equal to 4. So we shall start with Roman 1. Roman 1 we shall know that when there is a product and you split the 2 you get a sum. So product changes to addition when you split the 2 values. Then next we know that because this is a power, it can be brought down. So when you bring it down, you shall come up with 2 log m plus log n. Then from there I have to remember that log m is equal to a, and also log n is equal to b. That will come and substitute to come up with 2a plus b. So basically that's what they wanted. Now we shall go to Roman 2. Roman 2 says solve log x base 3 equal to 4. So this is what we have. Now to eliminate the logarithm, we shall say 3 to power 4 is equal to x. So that is a rule for eliminating logarithm. So you shall come and write that 3 to power 4 is equal to x. Then when I use a calculator, 3 to power 4 is equal to 81, implying that x is equal to 81. So basically that's what they wanted. Now let's see how much can be awarded. This one is for this expression, and A1 is for the substitution. Then M1 is for index form, eliminating logarithm, and A1 for the value of x. So now we shall go to question 3. Say that rationalize the denominator of this, then state your answer in its simplest form. So to rationalize the denominator, it means that if this is 3 minus root 2, we multiply up and down by 3 plus root 2. So up 14 will be multiplied by 3 plus root 2 to come up with that, and this one also down to come up with that. Then from there I'll have to open brackets. So for the numerator, 14 by 3 multiplied by 3 is 42. 14 multiplied by root 2 is 14 root 2. But for the numerator, this is difference of 2 squares, therefore 3 squared is 9 and root 2 squared is 2. Next to simplify, so 9 minus 2 is 7. So now next is to split the numerator. When I split the numerator, so I'll come up with this, whereby 42 over 7 gives me 6 and 14 over 7 gives me 2, and this root 2 is there. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for rationalizing, M1 for expanding numerator, and then another M1 for expanding denominator, and A1 for splitting the numerator. Now we shall go to question 4, which says that this: find the sum of the largest and smallest 4-digit numbers which one can form using the digits 4, 1, 6, and 2. So the largest number, it means that you arrange them in descending order. So start with 6, followed by 4, followed by 2, and followed by 1. That will be the largest number. Then for the smallest number, we arrange in ascending order. So start with 1, followed by 2, followed by 4, and lastly 6. But they wanted the sum, so we are going to add the two numbers and come up with 7667 as the largest, as the sum of the largest and smallest number. So basically that's what they wanted, and now let's see how much can be awarded. So B1 for largest number, B1 for smallest, M1 for addition, and A1 for output. Now we shall go to question 5, which says that given the functions fx equal to x squared and gx equal to x plus 3, find ff3 and gfg1. So ff3 means that you substitute fx into fx. So fx was this x squared, so when I substitute fx into fx, it means that where there is x, I'm going to put there the x squared. So this is what happens. So where there was x, I'll put the x squared to come out, and this square is this. Now when I simplify, this and this the same as product, so 2 times 2 is 4. So in the end I come up with x power 4. But they wanted ff3, so I come and substitute where there is x, I'll put there 3 to come up with 81. So that is Roman 1. Now we shall go to Roman 2. Roman 2, they want fg1. So fgx means that you substitute the value of fgx into fx. So gx is this, so where there is x here, I'll put there the value of, I'll put there x plus 3 to come up with this. So this squared is this. The next is substitute gf1, where there is x, I'll put there 1 to come up with 4 squared, which is 16. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for ffx, B1 for ff3, B1 for fgx, B1 for fg1. So now we shall go to question 6. Says that Mombeja, so this would have been Mombeja, has a vehicle whose current value is shillings 14.5 million. If this vehicle depreciates at a rate of 8% per year, find its value after 2 years. So this is depreciation. So first of all, you have to quote the formula for depreciation, which is P. This is the principal or initial value. Then R is the rate, which is 8, and N is the number of years, which is 2. So we are going to substitute those values. So note that this is minus because it is depreciation. If it was appreciation, it would have been plus. So substitute for P, substitute for R, and substitute for N. Next is simplify what is in the bracket to come up with this. So the whole of this is 0.92. Then when I use a calculator, come up with shillings, 12,272,800 shillings. So basically that's what they wanted, and now let's see how much can be awarded. So M1 for quoting the formula, M1 for substituting to the formula, M1 for simplifying, and A1 for output. Now we shall go to question 7. So question 7, Roman 1 says, state the position vectors of the points with coordinates M 74 and N -35. Then part B, P is the midpoint of displacement AB, where OA is that and OB is that. Find the coordinates of P. So let's start with Roman 1. So position vector is denoted by OM for M, and it is 74. And for this one, it will be ON, which is -35, as a column vector. That was Roman 1. Now we shall go to Roman 2. They want the midpoint of AB. So midpoint of AB is given by this formula, half of OA plus OB. So always note that half of OA plus OB. Some students confuse it and use minus. They say OB minus OA, which is wrong. So it is half of the sum, which is OA plus OB. The next is to substitute. So substitute for OA and substitute for OB. So OA was this and OB was that. So when I add, 3 plus 7 will give me 10, and 1 plus 5 will give me 6. Now this a half multiplies every entry inside the vector, so a half by 5 by 10 will give me 5, a half by 6 will give me 3. So that is the position vector of P, but remember they wanted coordinates. Therefore we shall come and state that the coordinate of P is 5, 3. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for both position vectors of OM and ON. Then M1 for substituting, and B1 for output, A1 for coordinate form. Now we shall go to question 8. Question 8, Roman 1 says, state the value of 2 in the number 6 to T4 base 12, and that is 1 mark. Then Roman 2, find the value of n given 102 base n is equal to 24 base 7. So in this case the value of 2 will be, remember this is power 0, power 1, power 2, so it will be 2 times 12 to power 2 to come up with 288. Then for Roman 2, it will be, we are given this, so you have to convert to base 10. So when I convert to base 10 to be, this is 0, 1, 2, so 1 times n to power 2, 0 times n to power 1, 2 times n to power 0. This is 0, 1, so it will be 2 times 7 to power 1, 2 times 4 times 7 to power 0. The next is to simplify, so this will give me n squared, this will give me 0, this will give me n, this will give me 2, because n number to raise power 0 is 1. So this gives me 14, this gives me 4, because n number to power 0 is 1. So when I simplify further, it will become n squared equal to 16. So next is put a square root to come up with n being equal to 4. So you ignore the negative because this was a base, therefore it has to be a positive value. That means that n was base 4. So with that, let's see how much can be awarded. So B1 for the value required, M1 left hand side converting to base 10, right hand side converting to base 10, and A1 for the value of n. Now we shall go to question 9. Question 9 says that express 3 to 4 as a product of its prime factors. Hence find square root of 3 to 4. So we shall come and draw our factor tree. So 3 to 4 can be divided is divisible by 2, so 324 divided by 2, I'll come up with 162. Then 162 divided by 2, I'll come up with 81. Then 81 divided by 3, I'll come up with 27. And 27 divided by 3, I'll come up with 9. 9 divided by 3, I'll come up with 3. And 3 divided by 3, I'll come up with 1. So that means that the product will be this times this times this times this times this times this. Therefore, I'll come and say that 3 to 4 is equal to 2 times 2 times 2 times, 2 times 2 times 3 times 3 times 3 times 3, which are these values. So when I pair them, this and this gives 2 squared, 3 squared, and 3 squared. That's why there is 2 squared in here, 3 squared here, and 3 squared there. But they wanted us to get the square root, so we'll come and say that therefore square root is equal to 2 squared times 3 squared times 3 squared. Because this power is the same for all and this is the product, it implies that it can become 2 times 3 times 3, everything raised to power 2. Now this square root and this square can cancel to remain with 2 times 3 times 3, and then I'll come up with 18 as my square root. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for generating the column of this, another B1 for the product, and B1 for putting prime factors under square root, and B1 for the required value. Now we shall go to question 10. Question 10 says that draw 2 separate arrow diagrams to show the relation Roman 1 exceeds by 3 between the members of set A, which is 1, 3, 4, 5, 6, 8, and Roman 2 is a multiple of between the sets P, which is 2, 4, 6, 8, 9, and 2, which is 2, 3, 4. So just start with Roman 1. So Roman 1, we shall first put these values inside that set. So that is 1, 3, 4, 5, 6, and 8. But the relation was this exceeds by 3. So first of all, you realize that 4 exceeds 1 by 3 because 4 minus 1 is 3. The another one is 6 because 6 exceeds 3 by 3. Because 6 minus 3 is 3, therefore 6 exceeds 3 by 3. So next is 8 because 8 exceeds 5 by 3 because 8 minus 5 is 3, therefore the arrow is that, so 8 also exceeds 5 by 3. So that is the diagram for Roman 1. Now Roman 2, they said, is a multiple of, but there are 2 sets, so we shall draw first one set, or set P. Then also we shall draw values of set 2. Then after that we shall use the relationship that is a multiple of. So we realize that 2 will be a multiple of 2, multiple of 4, multiple of 6, and multiple of 8. So you come here and draw those arrows. So first will be that 2 is a multiple of 2, and also 2 is a multiple of 4, and also 2 is a multiple of 6, and also 2 is a multiple of 8. Then when it comes to 3, 3 is a multiple of 6, and also a multiple of 9. When it comes to 4, 4 is a multiple of 4, and a multiple of 8. So that will be the arrow diagram for Roman 2. So basically that's what they wanted. Now let's see how much can be awarded. So B2, if all these 3 arrows are correct, that will be B2. If only 2 arrows are correct, that will be B1. If only 1 is correct, that is B0. Then here B1 for all the 4 arrows originating from 2 correct, and another B1 for both arrows from 3 and 4 correct. So now shall start section B, where we are expected to answer 5 questions from this section, and all questions carry equal marks. But for revision, we shall do all the 7 questions in section B. So question 11 says, a certain country's tax structure is such that a person's monthly income has some allowances deducted before taxation. Know that word, allowances deducted before taxation. The monthly allowances in shillings are as follows. So marriage allowance is 31,000, unmarried 15,500, medical 160,000, utilities 95,500, and child allowance 250,000. The tax structure is as shown below. So this is the tax structure. So this is the income tax, and this is the corresponding percentages. So Rugunda is an employee in this country and he earns a gross monthly income of shillings 780,000. He is a bachelor and has no dependents, meaning he has no children and is not married. Part A, calculate his Roman 1 taxable income, Roman 2 income tax, and Part B, express his income tax as a percentage of the taxable income. So we shall start with Part A, Roman 1. So we have to first get the total allowances. Since he is a bachelor, the allowance for married and the allowance for children is not indicated here. So the allowance for unmarried, we said it was 15,500, for medical it was 160,000, and for utilities it was 95,500. Therefore, when you add all these ones, you'll come up with a total allowance of 271,000. So what does that mean? It means that taxable income will be equal to this minus that. So when I subtract, I'll come up with shillings 509,000. So that was a Roman 1. Let's see how much can be awarded before we go to the next part. So M1 for addition and A1 for output. Then M1 for subtraction, A1 for output. So that was Roman 1. Roman 2, they want income tax, and Part B, they want express his income tax as a percentage of taxable income. So for us to get the income tax, we need to generate a certain table. So we have first generate a column of income tax. So for the income tax, it's got from this given table in the question. For example, this one, from this to this, we shall call it the first 100,000 shillings. Then from here to here, the difference is 50,000. Therefore, we shall call it the next 50,000 shillings. Then from here to here, the difference is 100,000. So we shall call it the next 100,000 shillings. Then from here to here, the difference is 100, so we shall call it the next 100,000 shillings. Then from here to here, the difference is still 100, so we shall call it the next 100,000 shillings. Now from here to here, remember our taxable income was shillings of 509,000. Therefore, 509,000 minus 450,000, I'll come up with 59,000. Therefore, that's why you put here the next 59,000 shillings. So that has been the column for taxable income. The next is to show the working. So for the working, we shall use these percentages. For example, for the first 100, it is tax free, so it will be 0 there. Next is 20%, so it will be 20 over 100 times 50. The next is 30, so it will be 30 over 100 times 100,000 shillings. The next is 35, so 35 over 100 times 100,000 shillings. The next is 40, so 40 over 100 times 100,000 shillings. And next is 45, so it will be 45 over 100 times 59,000 shillings. So next is to simplify. So you come and say that for this one it is still 0, but for this one it will be 10,000, this one will be 30,000, this will be 35,000, this will be 40,000, and this will be 26,550. So when I add all these ones, I'll come up with a total of 141,550. So I'll come and conclude that the income tax is shillings 141,550. So that was the income tax they wanted in Roman 2. Now let's see how much can be awarded. So B1 for this, B1 for that, tax for that, tax for this, so this, and lastly the total. So now we shall go to part B. So part B, the required percentage will be income tax over taxable income multiplied by 100. So income tax was shillings 141,550 and taxable income was 509,000 multiplied by 100. So we'll come up with 27.81%. So in Olevel math we use 2 decimal places, so that will be your answer. So M1 will be for substitution and A1 for output. So that has been question 11. Now let's go to question 12. Question 12 says the diagram below shows a right pyramid with vertex V and square base ABCD. Know that word, square base, of side 14 centimeters. O is the center of the base and length AV is 20 centimeters. Also, capital N is a point on BC such that BN is equal to NC. That means that N is the midpoint of BC. Find part A, the lengths of BD, VO and VN. Then part B, angle between Roman 1 VC and the base. Then Roman 2, angle between the planes VBC and ABCD. So now we shall start with part A. So let's start with part A. So part A, you have to extract a certain right angle triangle, and that will be triangle ABD. So if you look at this diagram, your right pyramid, we have extracted out triangle ABD. So for this triangle ABD, you realize this angle is 90 because it's a square, and this side AB is equal to this side AD. Therefore, what we don't know is BD, and that's what we want to get. So you come and say that by Pythagoras theorem, BD squared is equal to DA squared plus AB squared. So when I substitute, this is 14 and this is also 14 squared. So 14 squared plus 14 squared, I'll come up with 392. So when I put square root on both sides, I'll come up with BD being equal to 19.80 centimeters. So OB will be a half. So if you look at this triangle, if you look at this, this is the diagonal of the square, meaning O is the midpoint of BD. Therefore, OB will be a half of DB. That is why here we are writing that OB is equal to half of BD, implying that OB is equal to 9.9 centimeters. So now that we know OB, we can come and get the other length. So OB, it means that this is 9.9 centimeters, and VB is already 20 centimeters as it was given. For example, if you look at this, we want triangle OBV. So let's look at triangle OBV. If you look at this triangle O, B and V, you realize that this triangle is right angled at O. Then this slanting length is equal to this, so that is 20. Then OB, we have got it. Now we want to get VO, which was asked. So you come here and still use Pythagoras theory and say that VO is equal to VB squared minus OB squared. When I substitute, I'll come up with that. And when I simplify, I'll come up with VO being equal to the square root of 301.99, which gives me 17.38 centimeters. So now we have got VO. So next is to extract out the triangle of ONV. So let's look at ONV. If you look at ONV, this is O, this is N, and this is V. So when I extract out this triangle, you realize that they want VN is what they want, but from here to here is equal to half of this length, which will be 7 centimeters. Then VO is what you have got here, so you can get VN. Therefore, you come here and say that Vn is equal to Vn squared is equal to VO squared plus ON squared. Therefore, I'll come and substitute for Vn and substitute for On to come up with Vn being equal to the square root of 351.0644, which gives me 18.74 centimeters. So that was part A. Now let's see how much can be awarded for part A. So M1 for substitution, A1 for output, M1 for substitution, A1 for output, M1 for substitution, A1 for output. So now we shall go to part B, where they want Roman 1, the angle between VC and the base, and part Roman 2, the angle between the planes VBC and ABCD. So let's start with the angle between VC and the base. So for VC and the base, there is a triangle we need to extract out, and that will be triangle VOC. So if you look at this is the base ABCD, that is the base. Then they wanted VC, this is the line VC, therefore the angle will be this from here up to here. That is why you're extracting out a triangle CO and V, and that triangle is right angled at O. That is why you see a right angle at O. Therefore this is our theta 1, which is there. Then this slanting length was given as 20, and this VO has been got in part A as that, and this was got as that. So with that triangle extracted out, we can now go ahead and get the angle. So what you should remember is that now with this angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So it is you to choose which one you want to use. So if I use sine theta, it will be opposite over adjacent. So sine theta will be this opposite over opposite over hypotenuse, so which is 20. And therefore theta 1 will be 60.34 degrees. That was Roman 1. Then Roman 2, we shall extract out this triangle because it was between two planes. So for example, when you look at this, these are two planes. There is plane ABCD and also plane VBC. So with those planes, the angle between the two, for you to get it, you have to draw a line from here to the midpoint, then also from here to here, and the angle is that. So you already know that ON is 7 because it is half of AB. Then the height of VO is 17.38. Therefore you can easily get this angle, which is that. So you come here and say that this is opposite, this is adjacent, therefore we shall use tan theta 2 is equal to opposite over adjacent. Therefore theta 2 will be equal to 68.06 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for identifying the angle by drawing this triangle, and M1 for substitution and A1 for output. B1 for identifying the angle by drawing that, then M1 for substitution and A1 for output. So now we shall go to question 13, and question 13 says that in Walusimbi house there are 50 members who play 3 games. 24 play chess, 26 play tennis, 29 play volleyball, 9 play both chess and volleyball, 13 play both tennis and volleyball, while 11 play both chess and tennis. If each of these members plays at least one of the 3 games, represent the given information on a Venn diagram and use it to find the part A, the number of members playing Roman 1 all the 3 games, Roman 2 only 1 game, and part B, the probability that a member selected at random from the group plays tennis only, Roman 2 only 2 of the games. So here we are told that 24 play chess, 26 play tennis, and 29 play volleyball. So let's first represent those on a Venn diagram. So let the intersection of all be x, therefore our 3 sets will be drawn as shown. So first we know that the total number of members are 50, therefore the number of universal will be 50. Then those who play chess, volleyball and tennis, we shall come and put them there. 24 play chess, 26 play tennis, and 29 play volleyball. Then next we are told that 9 play both chess and volleyball, then 13 play both tennis and volleyball, then 11 play both chess and tennis. So let's first represent that. So first of all you have to put there this, the common down which is common for all. Then those who play chess and volleyball were 9, so it will be 9 minus x. And those who play volleyball and tennis were 13, so it will be 13 minus x. And those who play both chess and tennis were 11, so it will be 11 minus x. The next they told us that if each of these members plays at least one of the 3 games, represent the information on the Venn diagram. So each of them plays at least one, meaning that the complement of all the 3 sets is 0, so we shall come and put here 0. Now next is to get the value of x. So to get the value of x, we have to first put there those ones for A, B and C, to fill in the missing spaces of A, B and C. Then next we shall come and see that if I add all these ones, it will be equal to 24. So I'll come and say A plus 11 minus x plus 9 minus x it will be equal to 24. So when I simplify this side, it will be 24, which is this. Then this a is there, this x is this, because this and this cancels. Then 11 plus 9 is 20, which is there. Simplify further, a will be equal to 4 plus x. What about if I add up all the values in t? So that when I add up all those, I'll come up with this. Therefore by t is 26, so I'll come and put 26 there. This and this cancels, you remain with this, which is that. Then 11 plus 13 is 24, which is that. Then when I make b the subject, it will be 2 plus x. Next is add up all the values in v. So all these ones will add up to 29, so I'll come and say 29 is equal to c plus 22 minus x. And when I make c the subject, it will be 7 plus x. Now next is to add up all these values inside this set, universal set. So when I add up all of them, I will say the whole of this is 24, which is that. Then there is this b, there is this c, there is this 13 minus x. This is 0, so even if you don't put it here, so that total is equal to 50. So I'll come and say that 50 is equal to that. So b was got as this and c was got as this, so we substitute for b and for c and for total. So next is collect like terms. So add 24 plus this plus this plus that will give you 46. Then this and this cancels, you remain with positive x, which is there. Then this side it is 50. Next is to make x the subject, so x will be 4. So now let's see how much can be awarded for this slide. So b1 for this value, b1 for this value, b1 for this value. Then b1 for any of the three, so any two. So there is this a, there is this b, and there is this c. So in this case I used b and a, so it will be that and that. Then m1 for addition. So now that we have got the value of x, we can now come and replace x in the set we had drawn, and these are the values we shall come up with. Okay, so those are the values we come up with when we replace x in the above Venn diagram. So now we can answer the questions. So part A, let's first go back to part A and see what happened. So part A, Roman 1 wanted the number of members playing all the 3 games and those playing only 1 game. Then part B, they wanted probability that a member selected plays tennis only and another one for only 2 games. So let's start with all the 3 games. So for all the 3 games, it will be the value of x, which is for members. Then for only 1 game, it will be only 1 game, there is this, there is this, there is this. So we add all those ones, we add 8, 6 and 11. So when we do that, we shall come up with 25 members. Then part B, the one the probability of a member that a member chosen in the group plays tennis only. So tennis only is this, which is that, but probability is event over sample space. So the sample space is 50, so this is supposed to be 50. So sample space is 50, so 6 over 50 to come up with that. Then part B, probability that a member chosen plays only 2 of the games. So only 2 of the games, it will be there is this, there is this, and there is this. Therefore you have to add 5, 7 and 9. Then this total was 50, like I said. So when I add the numerator, I come up with 21 over 50, and that will be the probability. So basically that's what they wanted. Now let's see how much can be awarded. So A1 for output, M1 for addition, A1 for output, M1 for this, and A1 for the whole of it, the whole quotient. Then M1 for this numerator and A1 for the whole quotient. So now we shall go to question 14. Question 14 says the figure below shows a bullet of height 6.5 centimeters. The cylindrical part of the bullet has a diameter of 8 centimeters. Determine the Roman 1 height of the conical part, Roman 2 height of the cylindrical part, and Roman 3 volume of the bullet. So just start with Roman 1 height of the conical part, but for you to get the height you have to first extract out a right angle triangle. So let's first do that. So we have extracted out a right angle triangle, which is this. We can either use that or you use this. So in this case we shall use, let's use this because this side was already given. So we have this, this and this. Because right angled you can use Pythagoras theory. So you come here and say that h1 squared will be equal to 5 squared, which is the hypotenuse, minus 4 squared, and therefore h will be square root of 9, which is 3 centimeters. So that is the height of the conical part. What about the height of the cylindrical part? So for this height from here to here, we already know that from here to here is 6.5 and from here to here is h1, therefore from here to here it will be the difference. Therefore h2 will be equal to 6.5 minus h1, which is 6.5 minus 3, to come up with 3.5 centimeters. So next is to get the volume of the bullet. So volume of the bullet is equal to volume of the conical part plus volume of the cylindrical part. So volume of a cone is a third pi r squared h. So in this case h is h1, that is why we're putting here h1. Then for the cylinder, volume is pi r squared h. So h in this case it is h2. But radius is the same for all. Therefore we shall come and substitute. So substituting pi is 22/7, r is 4 because this was 8, divide by 2 get 4, h is 3 as it was got here, then here pi is that, r is 4, h is 3.5 as it was got here. So next is to simplify. So when I simplify this bracket, I'll come up with this 352/7. Then when I simplify this bracket, I'll come up with this, and when I add the 2, I'll come up with this, and when I use the calculator, round off to 2 decimal places, it will be 226.29 centimeters cubed. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for right angle triangle, for you to extract out that. Then M1 for substituting in Pythagoras theory, M1 for square root, and A1 for output. Here M1 for substituting and A1 for output. Here now M1 is for you to get the volume of the conical part, M1 for volume of the cylindrical part, and M1 for adding the two volumes. Then B1 is for you to simplify the volume of the bullet of the conical part, another B1 for simplifying the volume of the conical part, so the cylindrical part, and A1 for the final answer to 2 decimal places. So now we shall go to question 15, and question 15 says, given that fx is equal to 2x and gx is equal to x minus 3, determine part A Roman 1 gfx, Roman 2 fgx, and Roman 3 fg0. Then part B, determine the inverse of Roman 1 gfx and Roman 2 fgx. Then part C, the values of x for which fx over gx is meaningless. So in this case it was not values, it was just value. So you start with Roman 1. Gfx means that you substitute fx into gx. For example, in this case gf, so where there is x here in g, you'll put there the value of fx, so it will become 2x minus 3. So that is why there is here 2x minus 3 in gfx. Then Roman 2, they wanted fgx, meaning that you substitute gx into the function of f. Remember, fx was 2x, therefore where there is x, you put there the value of gx, which is x minus 3. When I open brackets, I'll come up with 2x minus 6. Then Roman 3, they wanted gf0, so you put 0 here to come up with negative 6. Part B, they wanted inverse of gfx, so we'll come and say that first of all, gfx, we have already got it as that. Therefore, to get the inverse, you are going to first let capital Y be this, and this one be capital X. So the next step is to make capital X the subject. So when I simplify what I've done, I've brought this 3 this side to become plus, then divide both sides by 2 to come up with Y plus 3 equal over 2. Therefore, we shall conclude that the inverse of gfx is equal to, where there is capital Y, now you put back the small x. This is 3 and that is 2. So that's how they get the inverse. Then for Roman 2, they wanted the inverse of fgx. We know that fgx is 2x minus 6. Therefore, the first thing to do is to let capital Y be that and this one be capital X. The next thing is to make capital X the subject. So bring this one this side to come up with this. Then divide both sides by 2 to come up with that. Therefore, you come and state that the inverse is, where there's capital Y, you put small x. Now there is 6, there is 2 there. So that's what they wanted in part B. Now part C, they wanted the value of x, for which this is meaningless. So for this to be meaningless, it implies that the denominator must be equal to 0. Therefore, for meaningless function, x minus 3 is equal to 0. Therefore, x is equal to 3. So basically that's what they wanted, and now let's see how marks can be awarded. So B1 for you to get gfx, M1 for substituting and A1 for the output, M1 for substituting and A1 for the output. Here for part B, Roman 1, M1 for letting, so this part is very, very crucial. Then M1 for making X the subject and A1 for you to set the inverse. Then for Roman 2, M1 for making X the subject and A1 for you to set the inverse. Here M1 for equating to 0, denominator, and A1 for the output over the value of x. So now next we shall go to question 15. So question 15 says Kampala and Masaka are 20 kilometers apart. A bus left Kampala for Masaka at 8:30 a.m. and moved at an average speed of 60 kilometers per hour. 40 minutes later, a car left Masaka for Kampala traveling at a speed, so this was supposed to be at a speed of 80 kilometers per hour. By plotting both graphs on the same axis, find Roman 1 the distance from Kampala to the meeting point of these vehicles. Roman 2 the time at which the two vehicles met. So the first thing to do, we need to have a graph paper. So that's the graph paper. Next is to draw the axes, horizontal for time and vertical for the distance. Next we have to label, so horizontal shall label the time in minutes. and we label the axis. Then vertical, we shall put there the values of the distance. Remember it was 120, so we have to go up to 120, and that will be the distance in kilometers. So this is the point of Masaka. This is now Kampala. So in this question they told us that a bus left Masaka for Kampala for Masaka at 8:30 a.m. So 8:30 is our 00 starting point, and moved at an average speed of 60 kilometers per hour. What does that mean? It means that in every hour it covers 60 kilometers. So that one will help us to draw our graph. So in every hour, so every hour has 60 minutes. Therefore, this from here to here is 1 hour. So you look for the 60 kilometers, which is that. Therefore, that is the point we need. So you come and put that point there. Then next is to draw. Now what you are going to do, we are going to draw a straight line using a ruler from this origin through this point until it meets this line. So let's do that and we see. So that is it, and we have to label that that is now the movement of the bus. What about for the second curve? So for the second one, it started 40 minutes later, but it started from Masaka going to Kampala. This one started from Kampala going to Masaka. This one is starting from Masaka going to Kampala, and the speed is 80 kilometers per hour. What does that mean? It means that in every 1 hour it covers the distance of 80 kilometers. So we shall come here and say, now after 40 minutes, this is the starting point. So this is 40 minutes. So it starts from here, and they told us that the speed is 80 kilometers per hour. So 80, so 1 hour is what? This is 20 minutes, 40 and 60. So this is 1 hour. So we need that also. Then next they told us that it covers 80 kilometers per hour. So from here to here is 20, 40, 60 and 80. So what does that mean? It means that now from here we shall need, this will be our point. So we are going to put a point here, and that is the point. Now that we have put a point, we have to draw a line from this point through this point until it touches this axis where Kampala is. So let's first do that. And that is the motion of the car. Okay, now that you have shown the graph, next is to do what? They said by plotting the graphs on the same axis, find Roman 1 the distance from Kampala to the meeting point of these vehicles. Then Roman 2 the time at which the two vehicles meet. So distance and time is needed. So you are coming and say that the distance when they meet is on the vertical axis. So this is the meeting point. This is the meeting point. So you draw a horizontal line to meet this point, and this will be the distance. So you have to read off that value, and that value will be 74. So you are coming and say that the meeting point is 74 kilometers from Kampala. So that was Roman 1. Now Roman 2, they also wanted the time. So we shall come at this very meeting point and draw perpendicular to the horizontal axis, which shows the time, and read off that value. So that value will also be 74. Therefore you are coming and say that time is 74 after 74 minutes. So they meet after 74 minutes. But the starting point time was 8:30 a.m. Therefore 74 minutes is the same as 1 hour and 14 minutes. Therefore when I add it to 8:30 hours, I'll come up with 9:44. So this is now 24-hour clock, but I have to convert it back to 12-hour clock. So I'll come and say that the two vehicles met at 9:44 a.m. So basically that's what they wanted, and now let's see how much can be awarded. So 2 marks will be for axes, both axes drawn well labeled and with the correct scale. B2 for the graph of the bus and B2 for the graph of the car, well drawn and labeled. Then M1 for attempting to find the distance. So for you to show this, that is M1. Then this one is for you to state the distance. M1 for attempting to find the time, so for you to draw this. Then B1 for reading off, and M1 for addition, and A1 for timing 24-hour clock. So now we shall go to question 17. Question 17, Roman 1 says, using vector method, show that the points P, Q, and R with those coordinates are collinear. Then Roman 2, if point P divides line segment AB internally in the ratio AP to PB equal to MN, M to N, show that the position vector of P is given by OP equal to 1 over M plus N on brackets N of OA plus M of B. Then Roman 3, if point T xy divides AB internally, know that word internally, in the ratio 3 to 4, where A and B are points with coordinates A with 5, 8 and B with -2, -6, find the position vector of the coordinates of T. So we just start with Roman 1. They want us to show that these 3 points are collinear, or they lie on a straight line. So first of all, we're going to first get PQ. So PQ is equal to OQ minus OP. So when I subtract 4 minus 1 is 3, 4 minus 2 is 2. Now that I also get QR, so QR is equal to OR minus OQ. So OR is that, OQ is that. So when I subtract 10 minus 4 is 6, 8 minus 4 is 4. Therefore I'll come up, this one can be reduced, or fact, because 2 is common. So when I factorize out 2, I'll come up with 3, 2. And I think to realize that this 3, 2 is this vector of PQ. Therefore, QR is equal to 2 PQ. What does that mean? It means that since PQ is a multiple of QR, i.e. QR is equal to 2 PQ, and Q is common to both vectors, QR and PQ, then points PQ and R are collinear. So always note that when concluding, because some students, when they write this, they think they have already concluded, but that is not complete. You also have to add on this point whereby the two lines share a common point, because if they don't share a common point, it means that they are parallel, but when they share a common point, it means that they are collinear. So that was Roman 1. Now we shall go to Roman 2. Roman 2, we are given that ratio of AP to PB is equal to M to N. Therefore, in fraction form, it will be AP over PB, and this side will be M over N. So next is to cross multiply this with this and this with this to come up with NAP equal to MPB. Then next I will know that AP is equal to OP minus OA, then and PB is equal to OB minus OP. Then next is open brackets, come up with NOP minus NOA equal to MOB minus MOP. The next is to bring OP on one side and leave the rest on the other side. So this one comes this side to come up with NOP plus MOP, and this one goes this side to come up with NOA plus MOB. The next OP is common in these two, so we shall come and say that factorize out OP to remain with M plus N in brackets, then OP outside equal to NOA plus MOB. Therefore, when I bring this one this side, I'll come up with 1 over MN in brackets NOA plus MOB. And I think that's what they wanted. Now let's see how much can be awarded for this slide before we go to Roman 3. So B1 for getting vector P2 and B1 for getting vector 2R, and B1 for expressing 2R in terms of P2, and B1 for stating the conclusion correctly. Then here M1 for the fractions, then this M1 for expanding and cross multiplying, so it's given at this point. M1 for collecting like terms, putting option one side, so it is good at this point. Then A1 for obtaining the required expression. So now we shall go to Roman 3. So Roman 3 said, if point T is equal to xy and divides AB internally in the ratio 3:4, where A and B are points with coordinates A with that and B with that, find the position vector and coordinates of T. So in this case, T is now our point P in the above proof. Then 3 is the value of M and 4 is the value of N. So we are going to substitute that in this formula. So OA is already given, which is that, and OB is that. So let's substitute that in the formula to get the answer for Roman 3. So know that OT is equal to that from the above proof for Roman 2. So we are going to substitute M is 3, N is 4. So come and substitute N is 4, M is 3, then OA was given as that and OB was given as that. So next is to simplify. So this gives me 7, which is that. Then this one 4 throughout by every entry. So 4 by 5 is 20, 4 by 8 is 32. Then here 3 by negative 2 is negative 6, 3 by negative 6 is negative 18. So next, when I add this plus this will give me 14, and this plus this will give me 14. So next is when I multiply 1 over 7 times 14 is 2, and 1 over 7 times 14 is 2. Therefore the coordinates of T are 2, 2. And basically that's what they wanted. Now let's see how much can be awarded. So M1 for substitution, M1 for simplifying the box bracket to come up with that, M1 for position vector, and A1 for this. So this was supposed to be A1 for coordinates of T. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on U.C.E paper 1 for the year 2019. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video for U.C.E paper 1 2019 has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.